We're going to revisit three-part compound inequalities. We've looked at these before, so remember that here we've got the -4 less than or equal to a -2x plus 5 over 3 is less than or equal to 1. And we want to isolate the x in the middle. So to undo, we're going to first move the 3 because it's alone. And because it's divided by 3, we're going to multiply each section by 3. So I'm going to multiply 3 by 3, and that's going to give me a -12 is less than or equal to, when I multiply this 3, it cancels, and I'm left with -2x plus 5 is less than or equal to, and then 3 times 1 is 3. So remember, do it times all 3 sections. Then I'm going to need to come back, and the next thing I need to do is to subtract the 5 from all 3 sections. And that's going to give me -17 is less than or equal to -2x is less than or equal to -2. I'm going to divide by -2 in all the sections. And remember what happens when I divide an inequality by a negative? That's right, you're going to flip this inequality sign around, so both of those, and I'm going to end up with a positive 17/2 is greater than or equal to x is greater than or equal to a positive 1. So if you notice, it's kind of changed the order of it, where this is my bigger number and this is my smaller. So typically you'll see this reversed, where you have that 1 is less than or equal to x is less than or equal to 7/2. I'm not sure how the book will put the answer on this, but either one, this would be my preferred answer. The book might have this one. All right, so now let's look at this next example, and notice in the next example that it contains a variable not only in the middle but also on the left and right sides. So here's my equals here, my inequalities here and here. And you see there's an x in this section, an x in the middle, and an x to the right. When this occurs, we're going to solve it by rewriting this inequality using the word and. So when it's stated this way, it means that 7x minus 1 is less than or equal to 7 plus 5x. So the whole thing right there. And I'm going to take this middle section here and say that 7 plus 5x has got to be less than or equal to 3 times 1 plus 2x. I'm going to go ahead and distribute it and get 3 plus 6x right there. So notice that middle section repeats here and here. So the left is less than the middle, and also true is that the middle is less than the right side. All right, so then just go about solving these. So I'm going to subtract my 5x from both sides, and I'm going to get 2x minus 1 is less than or equal to 7. Then add your 1 to both sides and get 2x is less than or equal to 8. Divide by 2, and you get that x is less than or equal to 4. And also true, come back up here, and this time let's, I guess, say subtract 5x here from both sides, so that I'm left with 7 is less than or equal to 3 plus x, and then subtract your 3, and you get that 4 is less than or equal to x. So I'm going to turn that around and put the x on the right side, so I'll get that x is greater than or equal to 4. Okay, and so then I have to then treat this like a compound inequality where I have the word and I'm looking for the intersection. So I have to confess, as I look at this, I made this problem up. So that's why it's coming out kind of a special case. But notice both sides have a 4 on it. So really I just have the one number 4 in all my inequalities. So for the first one, I have x is less than or equal to 4. So I have this. For the second one, I have x is greater than or equal to 4, which is this. And when I do an and, I've got to figure out what's in both of them. And what's in both of them is only that number 4 itself. So the answer on here is 4. Now, typically, it's going to come out to be some kind of an inequality, or it could come out to be no solution as well. But in this particular case, I get that x is 4. Now, this next one doesn't say try me, but I'd like for you to go ahead and give a try at this and see how you do. And we'll take a look at it next class.